Since 2011, the creators of C++ sought to modernize C++ by including, among others, changes, functional programming paradigm to C++. One of the first changes is the introduction of range-based for loop. Range-based for loop is a way to iterate the container without changing or modifying the content of the container. So this range-based for loop only applies to containers, okay? And the code syntax is as follows. As you can see, range-based for loop is much simpler and cleaner than the imperative for loop, okay? It begins with the keyword for, as usual, followed by, in closing parentheses, a declaration of the member variable. Okay, this is a variable that represents an element of the container. Okay, followed by a colon, this colon, and followed by the name of the container where the variable belongs to, and followed by, of course, by the body. Okay, the colon symbol is read as inside of or an element of. The container can be of any type data structure. In C++, it can be an array, a vector, a list, or a string, you name it. Okay, so let's have an example. In this example, we declare a string called greeting, this string. We define an uninitialized variable C in our for loop, okay, which pertains to a character in the greeting, okay. In the body, we print each character followed by an handle, so each character of greeting, HELLO, etc., printed to the screen followed by an handle. So the effect is printing it, okay, in vertical order because of the handle. Okay. Note that the reason that the characters are written correctly, okay, one versus H, second E, like etc., is that strings is a sequential container, okay? For non-sequential data structure like sets, maps, trees, there will be no guarantee that the elements will be processed in the order we expect. Also note that range-based for loop is not purely functional in the sense that the body of the loop can contain codes that modify external state. Like in our example, this cout is changing the state of the output stream whenever it is run in each step of the loop. Another functional type is the for each loop. Like the range-based for loop, for each can be applied to elements of a container. Remember, these functional loop types can only be applied to container. But it is actually a function taking in 3 parameters. The code syntax is as follows, okay? The loop starts with for underscore each. This is one statement for each, followed by inside the parentheses a pointer to the element, to the first element of the container, where the function where we are iterating, and a pointer to the end element of the container, okay, where the function is to be applied. Followed by a pointer to the last element, so we already said that, and then followed by the function itself. Okay, let's see an example. In this example, we declare an array of integers called x's. Okay, this one. Okay. Notice that there is no equal sign or assignment symbol between the variable and the initiation list. This is called uniform initialization, a concept introduced in modern C++ to allow initialization without assignment. Okay? So we will further discuss this later in the prerequisite to the exercise. Okay? Now, the for each loop, we are interested only on the third and the 12th element. So we input the pointer that points to the third element, which is xs plus 2, and the pointer to the end of the 12th element, the end, xs plus 12. Okay, and the last argument is a function. Okay, it's supposed to be a function according to the syntax of for each loop. Okay, we therefore define a lambda function. More on that later when we go to function. We define the lambda function into char, which casts an integer into a character. Okay, the output of the for each loop is printing hello OED. I will not explain you how it's done, but casting into char makes it a character. So apparently 72, 101, 108, 108 again, 111 when converted to char becomes hello OED. So having discussed all the looping constructs possible in C++, we now ready to discuss the next topic.